So once again, hello everyone. And today we start the second part of our course devoted to working on your corpus of scientific articles. So we will discuss lecture 7, and this stage is called preprocessing, and I do assume that it's quite important. So the next lecture would be devoted to analyzing text, but if we do not have a clean text, then the results of the analysis would be quite poor. That is why today we will discuss basics of Python. So sorry for those who are already good at Python, at programming, because during the first part of the lecture we would do very easy operations, okay, just to get acquainted. Well, we all have different background here, so it's quite reasonable. Then, so that deals with those two issues. We will learn a few functions, operators, and methods, and also regular expressions. And then we will proceed with something more interesting for everyone. We will use open libraries that help us to pre-process text. Because with you we discussed computational linguistics, and we figured out a few things that we need to do with the text to work with it further, to process it automatically, to analyze it with neural networks. And so before that, we will do a very short revision of this theory and then proceed with open libraries. So in fact, Python language, programming language, was introduced 30 years ago, even more than 30 years ago, but it became quite popular just about 5 years ago with all those natural language processing tools development. As for the basics, normally we need to download integrated development environment or just a notebook onto our laptop or computer to something like PyCharm, which is the most popular one for Python, to work with the code. Nevertheless, as researchers, with you we do use Google Colab tool, which is available from your Gmail accounts. And it is in fact a tool for researchers, as you can see, because it is impossible to, there is no infrastructure for a bot or an app there, but there is the opportunity to use Google processes, GPU, etc., to check out your hypothesis. So as a researcher, you can run your code, check out something there, and then it would be, the end, yeah. So here it is important to remember that when you work with your corpus, in fact that would be your home task, you need to upload the corpus in your Google Colab here. So just a moment, the functions will appear. So you can upload your document, your TXT document here, and then you need to copy root to it. And only here to sample data, you upload the document, and then you choose your document and copy the root to it. When adding this root to your code, your TXT file would be processed. But mind that as this tool, this platform, is just for the researchers to check out their hypothesis, the documents are not saved here forever. So you need every time to upload the document again. Yeah?
We can upload it to Drive and then connect.
Yeah, sure. That's another way if you just have it on your Drive. Fine. So then let's start with the main statement, which we will use for working with different libraries and modules. And this is the import statement. Just to check out whether everything works or not on your Google Colab, would you please now run the code, input these. Mind that you need to work in the window which is used for code with this button, play button, run button. So if you run this code, what do you get? You're welcome either to copy those code snippets from my notebook, or as it was suggested, you can just download the whole lecture, the Jupyter Notebook from our platform of the course teaching, then upload it to your Colab and then run the code with your own variables. So if we run input this, what do you get? Not going? Okay, the internet is not fast enough here, but we will try. Yeah, exactly. So this is just the statement about Python. And the main idea, the main peculiarity of Python is that it is quite a readable and rather easy programming language. So unfortunately, it seems like mainly you will watch my demonstration and then use the code at home for your corpora. So the first thing to learn about Python is that at this course we work with text, and the text is normally called string in Python. So we work with strings. A string is a collection of characters or letters. So the first string which normally people start with then programming, they just print hello world. Mind that in Python you can use single quotes to write the string, to code the string. Or you can use double quotes. These are the same. Single quote, I mean this apostrophe. But if you need a string of a few lines of text, then you need to use those triple apostrophes, triple quotes. Otherwise, it won't see it as a string. And it is very important for us to work with text for the machine to see that this is the whole text. So if we print hello world and run the code that we unfortunately can't do here, we can do it, but it's very, very slow. I finally got the result, input this. This is the Zen of Python, so the description of it just. And now if we run the code print hello world, it would just give us back this string. So as for variables, we can give them names, and normally in Python they give the names which have some sense. So not just x or xy, but the names should be readable. It's better than to have them readable. Normally we would just use the variable text and then deal with some operators which help us to work with the string or with the text. So let's look at a few operators. So built-in library for string is called string, and it includes a lot of operators. The easiest one, the basic ones, are first of all concatenation. So here if we have two variables, we can put some text there into those strings and then plus them and get the whole line, so the whole text. So this is the first variant. The second operator is repetition. So if we work with strings, it is possible to multiply them any number of times, but mind that when multiplying, the Yeah, here it is, yeah. Right, and the fourth operator is for the new line. For the new line, you can use \n, and then if you put it inside the string, so this operator works inside the string, it would start the next word with the new line like here. So, does the code run or not with anybody? No. Okay, so then just believe me and then you will try it out doing homework. Is it clear with operators what they do, what they are used for? Okay, right. So then the next that we should discuss is indexing. So when we work with text, doesn't matter how many letters or characters are there in the text. Each letter, character, or punctuation mark gets a number in this string. So normally with you, we will work with the variable text. And so here is our string. And if we want to get as output some signs of the text, we can use indexing. Mind that in Python, indexing starts with 0. This is the main thing. And so if we print 0 index and -1 index, -1 meaning the last sign of this text, then we get those. So the main two functions, so these were operators, indexes. Now let's go on with functions. The main two functions of Python are print and input. As for input, normally we put some variables and then set the values for them in quotes. As for output, we use the function print with brackets. And here we can do some operations inside. Another important function is define function, def function, when we need to do more operations inside the string. Let's start here with the f string and then come back to define. So f string is used if we need to change something inside the text, inside the string. For example, do you sometimes get spam? Spam, yeah? So normally, does it greet you with your name? Yeah, right. So if you try this code snippet at home, you will be able to do spam, to send spam yourselves. So how it goes? It goes with this f string. So it's kind of a special string introduced in Python 3, Python 3.6. And the idea is that, okay, here we have two variables. And then with f string, we always put 3 quotes. And then in those brackets, in curly brackets, we can add the variable here inside the string. And then all the values which are set for this variable will be added. So when they do spam, they have a list or a dictionary. We will discuss those sets a bit later. A list of emails with names, and so they just put those variables here in the curled brackets, and the email addressed to you would greet personally you. And so if we come back here, when using this f function, which allows us to change something inside the string with these curly brackets, we can greet a person, defining that this is greeting, with their name, and get here, hello Alice. And if we have a list of thousands of names here, that will also work. Is it clear about f string and def function? So f string, f is not a function. F string, it is a special string where we can, if we put f and 3 quotes before the string, then we can add curly brackets here, and inside those curly brackets we can do absolutely anything we want, because normally inside the string we cannot change anything. But if we add it here, we can do some mathematical operations, or in our case, add some values to this variable. And just an example of how f strings are used was about greeting people with the def function here in spam. Yes, so they add the variables about names connected to particular emails, for example, and then he'll greet you personally. Let me.
Why is this function usable? Hello request and return hello. And what is the объявление of the name equal guest?
Is it better now? Because I saw you looking like it.
Equal guest. Why we are in a description of a function describe
because here we can add the whole list of different, for example, guests. It's just an example. It shouldn't be a guest 100%, just a list of guests or a list of emails for this variable.
if we run a function without a string, it return hello guest.
Yeah,
If
if
run greet,
it will return just guest. Yeah, if it's not, we can then it would just return the only value for this variable. Yeah, and if we use the list of names, then it can add the name attributed to a particular person, for example, to a particular guest or to a particular email. Probably we should discuss the lists, yeah? That would make it easier. So we will come back to lists and dictionaries. Okay, let's go on with them then. So there are different collections of texts of items that can be stored in Python. So normally these are key value pairs that are used as dictionaries. So if I do believe that from different collections that are available, like sets, lists, and others, for your corpora you are not obliged to use, but it's better to use a dictionary. That would make sense, and I would now try to illustrate why. So a dictionary is a collection where each variable has some particular values. For example, here the name is Alice, the age is something else, and so on. And it looks like a table. It might be a table initially, and then to work with the rows of the table, you just use those variables and print the values, adding them to your strings. And here, so we will get that Alice is not from a particular city if we use this particular dictionary, because we have those values here. And so coming back to our spam example, if we have a dictionary of particular organized values for some rows, then we can multiply this greeting. That was about f strings and dictionaries. Let's go on with methods now. So this is the easiest basic things that we need to do while preprocessing our text. So first of all, we can count the signs in our text, what we can see in Word or anywhere, and it is done with the len method. Methods are normally written with brackets afterwards where you put the variables. So here in Leo Tolstoy, it has 10 letters. Yeah, that's correct, without. Then methods of the case. We've noted with you that if we use a model which is not pre-trained before, then the words in upper and in lower cases are different for this model initially. So if we write the name with a capital letter and then the same name with line letters, then it would be understood as two different tokens. That is why normally we use the lower method to make the whole text, the whole corpus, lowercase. But here in this example, I've used the method upper somehow to illustrate how caps lock works. Then the third method to be discussed is the split method. So obviously it can split a string into a list of words. So here it is. So if we have the tokens just written with each with its own quotes, then it's called a list of words. And this is a way of easy tokenization word by word, but we will see more sophisticated ways of tokenization as well and compare them in half an hour. Another method is to do the opposite, to join elements of a list into a string. So again, if we have a list of words, so a dictionary is a set which has some attributed values, and a list is just a set of particular words. And so if we use the method join, then the list of words would be joined into a string, into a text. Finally, the last method to be mentioned as an example is the replace method, which is used to substitute some words in the string. So if we have this string and then we use the method replace or substitute, we can substitute some words. For example, like we mentioned with you in machine translation, we normally use a glossary. And so for your corpus you can replace a few synonyms of a term, for example, with one particular term which you consider. And then as a result, you will get, as you see, the string with the word which was replaced here, or bigram, or whatever. So these were basic operators, functions, and methods that you can use for strings, for lists of words, and for dictionaries. Do you feel the difference between a string, a list of words, and a dictionary? Fine. Do you feel the difference between different operators, functions, and methods? Yes, right. Great.
JSON format is not such popular way.
Yeah. Fine. Then let's discuss regular expressions, kind of in addition to what was mentioned. So for regular expressions, we input rem. And then we can use different patterns. So regular expressions, they work with patterns that should be searched in your text, or there are some other regular expressions. We will look at a few of them. So the easiest one is search. So if you have a text, so here might be just a string or a whole corpus, and then you set the pattern, you set the value, and search the text. Then the result, the output would tell you whether, if you put it as a function if else, whether this or that particular token is found in the text or not. At the same time, if you are interested in how many times it is found there, then you can use the regular expression find all and do the same. So you have a text, then you set the pattern, and you search for the particular pattern that might be a token or just a part of it, a syllable or whatever, or any signs. I do believe that this makes sense for mathematics, for chemistry, for biology, because this is the best way to find some particular signs which you can come across in the articles. Normally this is the only way to look for them. Although, of course, unfortunately, sometimes we do come across just pictures, illustrations in the articles, and then it's much more difficult to find something. But normally, if the journal follows the instructions how to code those formulas, for example, then it is possible to search for particular signs with regular expressions.
What's the difference with rare library and find method?
Then it would find all would give you as a result all the cases whether it came across it, so it would count them.
If we write a string, what find something.
Yeah, of course. There are hundreds of ways how to do it. These are just examples. I won't just show you per each operation all the variants how to do it. You can do it with string. Yeah, sure. So in general, that's a very important remark, that you can do the same things with a lot of variants of libraries or just methods or functions.
Find literally for symbols, or it can find a word in different form?
No, this is for particular tokens. It won't work with different forms. So here, that is why we need first to lematize and to stamp the document, and then only to use this search if we search for different forms of the same term, for example.
If you find Spain, it will find also Spain's.
Yeah, that's true. It would find the particular signs, yeah, but it would give you as a result just those signs, so you won't know that here Spanish is used. It would, you will get just Spain from it. It would cut everything.
We would found idiosh, idiom, and something.
No, it would found just yes, just these signs. It looks for particular signs, yeah. So on the one hand, it might be useful. On the other hand, it might cut a lot of information. Right, okay, then the next regular expression is for replacement. So again, to substitute something in the text, for example, to use your glossary, you can set a pattern and then use a regular expression for replacement of this pattern, and then you get the text with the replaced item or pattern. And finally, again, you can split the text with regular expressions, kind of easy tokenization again, and here it would omit all the signs. For example, if like here there are a lot of signs, and if you look through your own TXT document and see that there are a lot of additional signs, not just punctuation, for example, when converting the document to TXT, they might appear. And then the best way to split the text into a list of words, into a list of tokens, would be to use regular expressions. To put it mildly, normally it's better to use open libraries like NLTK for tokenization. But if the text initially has a lot of rubbish here, like this, which is not a punctuation mark, then you can use regular expression. It would work better with absolutely raw data. Is it clear with regular expressions? So that was kind of introduction. Let's now revise a bit what we discussed with you previously in the course, and then we will look at a few libraries that you are supposed to use in your home task. So may I now ask you to discuss those 5 questions in pairs, trying to revise what we had, in fact, in lectures 4 and 5 here. So take about 5 minutes trying to remind each other what was there. Okay? Can you see all the questions? The 5 questions of revision? Okay, right, so take your time. Okay, so shall we sum it up all together? So the first question, what mechanism and function are different in transformers compared to, by the way, what does RNN stand for? Brilliant. And so the new generation of neural networks, transformers, how they differ from recurrent neural networks? Which mechanism is crucial? Mm-hmm.
Because they can read, like they can not read, but analyze right context and left context.
Mm-hmm.
And neural networks only work like word after word.
Okay, right. So when analyzing, doing this backpropagation process, which mechanism is used to weight different errors on the layers of the neural network in transformers?
I think the main idea is that transformers, the mechanism is self-attention.
Absolutely, yeah.
For RNS, it always depends on the previous one.
Mm-hmm.
It's slower to train everything. But for the transformers, it can have access to each element simultaneously. So.
Yeah, exactly. So the neural network is able to pay attention to different parts of the process, to different layers, to come back to them, and then to weight the results, the errors. Right, so just that was generalization, so to say, of course, with no details. Okay, the second question, what are the differences between encoders and decoders? Because any transformer has those 2 parts in it, but there are encoder transformers and decoder ones. So what is the difference? We can start with the examples. Yeah, you're welcome.
For encoders, it concentrates on the input.
Mm-hmm.
For example, would be word.
Mm-hmm.
Decoder is about the output.
Mm-hmm.
You don't use a decoder for ChatGPT.
Exactly, yeah. Right, so for text analysis, what do we normally use mostly? What are the tools backed on? Yeah, not for generating, but for analyzing. Encoder, yeah, something like Word or all those branches of it. Right, what about transfer and reinforcement learning? What is the difference between them? Because mentioned above BERT and GPT, they use those 2 different techniques of learning, 2 different methods of learning. Yeah?
Reinforcement learning is from psychology.
Mm-hmm. Okay.
It is about when we learn something with positive or negative only a GPT model uses polarized it because uses model and can give a lot of data feedback on models.
Absolutely, yeah. So feedback and the interaction. Now the key things here, what about transfer learning? What is most important for it? What does it back on? What does it rely on? Not on the feedback, but on what? On the data, sure. On its experience, on the previous results of similar inputs. What about synthetic data? So just a few months ago, half a year ago for sure, it was said that it is impossible to learn on it, and synthetic data is the reason for hallucinations. What about now? Is it used, synthetic data, for learning, for machine learning? Obviously, yes, yeah, if a few months ago not, but now, yeah, it is possible to use it, and according to a lot of articles on it, it brings good results. Okay, so when preparing your corpora of articles, you did two things, information retrieval and partly information extraction. What is the difference between those two processes, retrieval and extraction of information? Okay, a good word. So, for example, consensus as an AI tool which processes the data from articles. Does it process, is it an example of information retrieval or extraction? When it summarizes the answer to your question from the articles? Extraction, exactly. And if we address some databases, then it's just information retrieval. And finally, computational linguistics that we're going to do now and next lecture. What three branches of it do you know? What can be computed in the text? These are the three levels for computing.
Statistical, count words, count letters. Letters. The second level is semantic, maybe, where we can count meanings.
Sure, semantics, yeah.
And the third level is the language speaking level, where we can count the global meaning and idioms maybe.
Okay, I like how you put it, but you look from the technical side of it, from the technical angle. But if coming back to linguistics, you mentioned one of the levels, which is the basic one, the semantic level, and in fact computing on it, computing syntagmatic and paradigmatic relations. It helps with the global meaning, with figuring out idioms and so on. Not very successfully up to now, but still. What are other levels of language that can be computed? Sure, yes, syntax grammar. So then if we speak about syntax or grammar, then the whole sentence should be analyzed as a context, yeah? And finally,
Phonology?
sorry?
Phonology?
Phonology, yeah, but this is something additional to semantic level, yeah, because depending on different phonemes, we can differently understand the tokens, right? As for semantics, we just figure out which meaning of the word is used here, relying on the context. But the same meaning, you remember a few memes that I used in the previous lecture, yeah? the words, there might be 2 or 3 words used in a row, but the combination of them, even having the same meanings, each of them, can give us different results. So you remember the example with parrots, yeah? With the question, can you talk? So in fact, the meanings of the words, the semantics is the same, but relying on the whole discourse, so if the context around the sentence is analyzed, we can figure out that although the semantics is the same inside each token, but it gives us different results, yeah, as the whole sentence. So I would say that when we deal with pragmatics, we try to figure out the meaning of the whole sentence. So we deal with the utterances. You remember we mentioned that in computer-mediated discourse, each sentence is an utterance having some particular, that can be clustered to a group of similar meanings, the whole sentence, the meaning of the whole sentence. Right, so thank you very much. You managed with the revision altogether. Let us now complete this lecture with the most important part of it and discuss the open libraries for pre-processing texts. So the initial one is the built-in string library, and we have already looked through a few methods that are used with this library. Like lowercasing, for example. And I would say that most of the operations and methods that you can do with the string library can be also done with regular expressions. But we tried in the discussion with you to figure out in which cases it is better to use just string library, which is built in, or when it is better to set some patterns for some particular cases. As for the basic pre-processing libraries for English and for most European languages, the number one is the NLTK, Natural Language Toolkit. This is a library which can be used both with Russian and English and most European languages. It is backed by many linguistic corpora, including, for example, the WordNet thesaurus that we mentioned with you during the first or the second lecture. So within LTK, you can tokenize the text, do lemmatization, stemming, all the operations of pre-processing. In fact, you can just deal with an LTK and do everything, all the main stages of pre-processing just with it. But normally, when we deal with a particular corpus, we figure out that, okay, here we need regular expressions to search for particular symbols in formulas, for example. Here, okay, we understand that there are a lot of additional symbols, so again, better to use something else. At the same time, we can use some equivalents of an LTK, for example, for Russian language, because when doing lemmatization, it is quite different from stemming in English, and we will see it in a minute. And then it is better to use some Russian-based libraries which work with the Russian language in particular. So NLTK is the basics, but normally you never do just with it, because you need to correct something, to transform something, taking into consideration the peculiarities of your corpus. Another library is Spacey. It is a bit more complicated, and we will look at it not at the pre-processing stage, but we will have the examples of code snippets with it during lecture 8, when we will discuss the text analysis operations. I would say that the basic tasks that you can do with Spacey is part of speech tagging and named entity recognition. Although, again, it's possible to do it with an LTK, but seems like Spacey would give you better results, especially in named entity recognition. As for the Russian language, so within this course, probably you have mainly the articles in English to be analyzed, but as here there are students from linguistic faculties and philological faculties who might work with the Russian language. The main three libraries to be mentioned are Pymorphy and Razdel, which can be used for the preprocessing tools. They are kind of similar to NLTK. I would compare them, they're almost parallel. And in addition, we should mention MyStem, which can be used as a software, or which can be, again, used in Python. It provides functions like lemmatization. For Russian, it is better than international libraries, and morphological analysis as well. So this is the basic list of libraries. And let's look at the text preprocessing stage. So, no, always, it all starts with tokenization. So the tokenization might happen at different levels, and partly they were mentioned when we discussed computational linguistics. So the basic one is word tokenization, when the text is split into words. And normally we deal with words, or words are unigrams, just one word, or we can deal with n-grams, like bigrams, for example, when we search for the combination of two tokens. Nevertheless, this is not the only way of word tokenization. We can also tokenize sentences, which makes sense if we do the sentiment analysis. One of the ways to analyze your corpora is to use the libraries for sentiment analysis. So to figure out positive and negative attitudes to some tendencies in your corpora. And in lecture 8, again, we would deal with those libraries for sentiment analysis. And here sentence tokenization might be important because because normally if we do sentiment analysis, it gives us better and more detailed results if we analyze whole sentences as utterances, not just words. The third variant of tokenization is tokenizing individual characters, in other words, tokenizing letters. And finally, we can tokenize parts of words, almost equal to syllables, but not always. That might be helpful in some tasks, but more linguistic ones. So for your projects, probably you would need just the first two variants of tokenization, basically word tokenization, and if you want to do some sentiment analysis, it's better before to tokenize the word as into sentences. So for tokenization, I prepared here 3 variants of libraries, but of course the list is much longer. So the first variant is to tokenize with a string library, which is quite easy. You just split the text into tokens. But mind that here you can see that all the punctuation marks, they're kind of plussed to the words. And that is not good at all, because the word would with a question mark won't be the same token as just the word would. So if you use string, better first to eliminate all the punctuation marks and numbers and stuff like that, and only then to tokenize. If you use here regular expressions for tokenization, then you set the pattern. Here it is. Then you ask the expression to find all the patterns, meaning all the words, but without any signs. as we mentioned with you, as we noted with you, regular expressions are good at eliminating different signs. And so here you can see that punctuation marks are not tokenized at all, which is quite convenient. Finally, as for the Russian language, here is an example how раздел is used for tokenization. Mind that if you run the code and you have the problem with the imported library, perhaps you need to install it beforehand. So in Google Colab, you need to start the line with an exclamation mark, then pip install the library. And here it is necessary because for Russian libraries, they are not built in, so it is necessary first to install them. So if we tokenize with раздел, then here we get all the results as well. So as for low casing, obviously you will use just the string library because it's quite a straightforward task. The result will be the same always. You just get the text in lowercase without any capital letters. So once again, for punctuation and numbers as well, so automatically, if you tokenize with regular expressions, you would avoid punctuation marks. But you can here add some additional signs which are not the punctuation marks into the list, and they would be omitted as well. With regular expressions, at the same time, you can remove numbers if it is needed for your task. So you use, again, just the pattern, but for numbers, and you, as in my example, they are removed. So these are the basic operations. I would say that normally we first lowercase the text, then we tokenize it, removing punctuation and numbers, and then we need to work with stop words. It makes sense first to remove the stop words and then to stem or lemmatize the text already without the stop words. For stop words, 100%, it's the best variant for starters is to use an LTK library. It has the sets of words in English, in Russian, and in a lot of other languages. So here you can see that we import the library, then we set the variable, we tokenize the text, and then we use the module of stop words with the set of English stop words, and then we get back the text without those stop words. In my example, I got rid of the A article, for example, if conjunction, and so on. So all the function words are already in the list, but you can add any words that you want to get rid of into the list, and they would be removed as well. So is it clear how to tokenize, how to remove punctuation, numbers, and stop words? Right. Then the next stage is lemmatization or stemming. So in both cases, our idea is to get in computational linguistics what is called normal form of the word. But these two operations are slightly different. In stemming, we would just get the roots of the word, not the basic forms like in lemmatization, the basic forms meaning the dictionary forms of the words. And in stemming, these would be just the roots of the words. So I think that we mentioned with you while discussing computational linguistics and those phrases with no meaning, like Glocka Kuzdra, like all the something furious green by Noam Chomsky, just slipped my mind. Right, and so taking into consideration the grammar structure of the language, a lemmatization better works with Russian. And here again seems like Russian libraries would suit better. For example, here we have a code snippet with using MyStem library. Again, it should be pip installed as it is a Russian library. And then the text, this poem in Russian by Alexander Pushkin, is lemmatized. And so here is the result. For example, унылая пора очей очарования, we have око очарования, and so on. If we use an LTK for lemmatization for Russian language, the result would not be always with the dictionary forms, so better to stick to it. As for stemming, we can do it either with regular expressions, but that seems a bit clumsy because then we need to copy all the patterns that we want to remove. This $sign here means that we remove those patterns, those suffixes, if they are at the end of the word. But so we need to set all the patterns that we want to get rid of. On the one hand, it's quite customized because we can add something from ourselves. On the other hand, it's a bit time-consuming and clumsy. However, it works. Here we have the word checking, and here we have the result chuck. I would say that stemming with an LTK is the easiest way. So stemming and removing stop words with an LTK works absolutely well. An LTK uses WordNet thesaurus for stemming, and here so we get without any patterns the same result, just itself. If we use stemming for Russian, that would be quite strange because we will have the examples that you noted today already, that we put the form iti, but it would be cut to it, and that will be all. So there would be just a lot of non-existing words, so it doesn't make much sense. Do you feel the difference between stemming and lemmatization and the tools that might be used? So once again, here are just the examples of the tools. Of course, other libraries might do the same. So, and in your projects, if you are competent at it, you can add something that you prefer. These are the basic variants that might be implied. Finally, at the pre-processing stage, normally we conclude with counting the frequency of certain tokens, or better of n-grams. So after the text is pre-processed, the results won't just lead us to the list of function words, but if taking into consideration the lemmatization or stemming process, it would give us the frequency of most important keywords for our corpus. On the first stage, it's quite reasonable just to count the frequency of separate tokens or unigrams having just one word, single tokens. However, I do believe that the results might be more detailed if we search for bigrams or even trigrams. You can just try it out on your corpus and you will see whether which results are more valuable for you, give you more information. So to work with n-grams to count frequency, we can again use NLTK like in cases with stop words and stemming. And here we would use another module and count the n-grams. So with this variable n, we set the number, whether it is 1 unigram, 2 bigram like here, or 3 trigram. And so then we will count the frequency, and here you can see the result that I have in this phrase. So to sum it up, what you need to do at home with your corpus, you need to upload it to your Google Colab. either having it on your cloud or uploading it here. Then you would copy the root to your document and set the variable to read this document. Even at this stage, there are a few variants how to upload and open the document. Before it, normally we we note all the libraries that we're gonna use and the modules from those libraries that we need. So for sure you will use string library, you might use some regular expressions, and an LTK library 100% too. As for an LTK library, you might use stop words or other modules. So what are the stages, the basic stages of preprocessing? First stage after uploading is lowercasing. Second stage is removing punctuation and digits. Third stage is tokenization. Fourth stage is removing stop words. Oh, I missed here the fifth stage of lemmatization or stemming. And then finally, you count the tokens or bgrams or 3grams. And here, depending on the length of your corpus, you would set the number of most frequent frequent n-grams that you search for. As an example here, I just used the War and Peace, which is known to be a very longish novel, but with a bit faster internet, it's quite easy to preprocess it and count the words in a few seconds and count the most frequent n-grams or bgrams or whatever. So at this stage, as the result of this task, you need to get those frequent n-grams or bgrams or something. So once again, the whole algorithm is normally written like this, with importing libraries in the first place, but it's not so important for the result. In fact, so if you just copy the code snippets from here and run them in a row, it's not a problem. The main idea is to get the result, the frequent words. I would say, relying on the experience, that if we consider scientific articles, the kind of surprising results, something new that you can find, appears if we analyze something around 100 of articles, or just 40 or 50 as you have. Still, you can find something interesting if you here set around 50 or 60 n-grams, because of course the first 10 or 20 results would be quite obvious for you. Yeah, these would be almost the keywords of your research. But if you search for 50 or 60 bgrams especially, or 3 grams, then you can find something new. You can pay attention to some tendencies that might have been omitted before. Nevertheless, I want to here emphasize that this is not the result of your research. This is just raw data about the texts. And if you do not have enough time to analyze thousands of articles or even hundreds of articles, you can process them like this and figure out something, some more tendencies, some more terms, some more results that should be analyzed by the researcher further. So this just gives you the roots for further research. Here at the end of this lecture, I have a table of, so to say, my personal preferences in those libraries for different stages of preprocessing. But this is not a rule for you. You just choose whatever you prefer, whatever works without errors. You can, if you still have an error in some code snippet, you can just use another library, not to get crazy about it, not to get mad. And once again, another thing is that probably you all know that nowadays GPT is quite good at generating code, and even some equivalents can do it quite well already. So you can either use my code snippets, or if you are not satisfied with some results at your particular corpus, you can ask GPT to, for equivalents of the same libraries, because we can't with 1 hour and a half discuss all the variants here, and we can't kind of know all the peculiarities of all your corpora. So this is the fundamentals that we stated today. Then it depends on your time and effort, whether you would just use this, and perhaps that would be enough to figure out something new from the articles, or you can enlarge it and develop. Any questions about preprocessing? Then you need to deal with lists and dictionaries. Probably that's a very good question. I would add to the task on the platform a code snippet for this case, because you need, in fact, to analyze them separately. Otherwise, the result would be very raw and so yeah, good question, so we will add it. Here, dictionaries and lists would help to distinguish between those two languages in one corpus. Okay, fine, thank you very much. So we will discuss in lecture 8 how to analyze those frequent expressions.